Hello everyone, and welcome back to another remote sensing lecture video. And in this lecture video, I want to continue our discussion on visual enhancements. By talking about contrast stretching. And I'm going to spend this video sort of conceptually talking about what contrast stretching does. And then the next two videos, I'm going to give sort of explicit examples in terms of showing you the histograms, and then showing you some examples with imagery, and why contrast stretching is really important. But to understand what contrast stretching means, we need to go back again and think about your computer monitor, right? And so when we talked about display channels, right, we talked about this idea that you have your pixel, your monitor pixel, right? And in the back of it, you had the red, the green, and the blue diode, right? And when we talked about display channels, we said, okay, the band assignment controlled what wavelength regions dominated or controlled how much red, green, and blue were being produced. What contrast stretching does is contrast stretching relates pixel values to display values. Now, what is a display value? So, just like with band assignment, where the display channel was whether you were talking about red, green, or blue, and it was that interface between the bands of your raster or your image and the red, green, and blue diodes of your monitor, right? A display value, contrast stretching, takes the pixel value that is in your image, right? The value that's actually in your pixel of your image, and translates it to what's called a display value. And so a display value is basically a number between 0 and 255 that controls how much light is emitted. Okay, so let me try and explain that a little bit clearer again. All right, so in the back of your monitor pixel, there's a little red, a little green, and a little blue diode. These diodes operate on 8 bits, so 0 to 255, that tell this diode how much blue light do I emit. Okay, so if it's 255, lots of blue. Right? If it's 0, that means no blue. All right, I'm just using blue as an example. You're going to have 0 to 255 for blue, for green, and for red. Where 0 means don't emit any of that color, and 255 means emit all of that color, as much of that color as you can. All right, so this 0 to 255, this display value, you can think of this as the control knob. This is the control knob for the diode, which is the thing on the back of your monitor pixel that's actually emitting light. And contrast stretching, right, relates pixel values to display values. So what do I mean when I say that it relates pixel values to display values? You have to remember something, right? One of the characteristics of an image was this idea of radiometric resolution, right? And this was also called bit depth. right? And this controlled, again, just sort of recap, right? This controlled how many choices the sensor had for defining a pixel value. Right? We went through all of those examples where you have radiation coming off the surface, hitting the sensor, and the sensor has to make a decision of what it's going to assign that pixel value to based on how much radiation it received. And if you have a really high radiometric resolution, right, you have a lot of different options. So you can really have fine scale delineation between the different amounts of radiation. If you have a low radiometric resolution, right, you didn't have a lot of choices. And we said that you could have anywhere between 11 and 16-bit imagery. Well, if you have 16-bit imagery, right, that is negative 32,768 to positive 32,768, right? So this is the full range of pixel values, possible pixel values, that a 16-bit image, like our Landsat image, right, that those pixel values could take. Well, I just told you that the display value, what your monitor understands, right, the control knob that you have to determine how much red light this little diode is emitting, right, it only understands values of 0 to 255 in whole numbers, right, 0, 1, 2, 3. You can't have fractions, right? So how do we go from negative 32,000 to positive 32,000? How do we go from this to 0 to 255, right? That is what contrast stretching does. And if this doesn't make sense, hopefully when we go through examples, it will. But I just want to reiterate this one more time. Contrast stretching takes your radiometric resolution, which could be very large ranges, right? 16-bit, negative 32,000 to 32,000. And it compresses those down, right? It combines them together in some cases to get your display values, which goes from 0 to 255. Hopefully that made sense. And as always, please reach out. Thank you.